All right. So in this one, basically for f of x, if we want to identify them, then basically if you remember from a graph on the inverse, you can see that the points on a graph and its inverse are swapped. The x and the y are swapped. So algebraically, that's exactly what we're going to do. We're going to swap the x and the y. And if you are unfamiliar with the really f of x, that represents the output variable, which also graphically can be represented as the y. So you first step, if you have function notation, is to replace f of x with y. Then we can go ahead and swap the variables, which is going to represent the reflection about the y equals x line. And now what we need to do is just go ahead and solve for y. So what I'm going to do is I'm going to multiply by a 5 on both sides. Again, those 5s will divide out, so now I'm left with a 5x equals a negative 15 minus 7y. Add a 15, so therefore I have 5x plus 15 equals a negative 7y. And this one's kind of very similar to the last example. When you write y, you can write it as, or actually let's write it. So now I have y solved, but again, typically what we like to use, rather than using y, we like to use the inverse notation because this y now represents the inverse. So I'm going to swap y with f inverse of x, which would be 5x plus 15 over a negative 7. Or if you wanted to write this kind of like in slope-intercept form, you could have this as a negative 5/7 x minus 15/7. So that's just an alternative way to write the problem.